Hi guys, it's Miss Austin. I'm going to be doing the lesson 5 practice problems. It says, number 1, what is the value of, this is a doozy, 4 times x minus 2 times x minus 3 plus 7 times x minus 2, x minus 5 minus 6 times x minus 3 times x minus 5. Excuse me, when x is 5. So I'm going to put a 5 wherever I see an x. And I'm going to kind of just do this math in my head. So this is going to be 4 times, if I put a 5 right there, what's 5 take away 2? 3 times, if I put a 5 right there, what's 5 minus 3? 2. Plus 7 times, put a 5 right here, 5 minus 2 is 3. 5 minus 5 is 0. Minus 6 times, put a 5 right there, 5 minus 3 is 2. 5 right there. Oh my goodness, another 0. Now, you do have to follow correct order of operations, which is multiply before you add and subtract. So you got to figure out you've got to do this set of multiplication, this set, and then this set. And then when you're done, you would add and subtract. But I already noticed right now, look at this. 0 times anything, that's all gone. And that's also gone. So really, it's just this. 4 times 3 is 12. 12 times 2 is 24. That becomes 0, and that becomes 0. So the answer is 24. Which polynomial function has zeros when x equals -2, 3/4, and 5? So remember, finding the zeros is setting this equal to 0. And if these three things are being multiplied together, in order for that to equal 0, one of those has to be 0. So basically, you're saying this to yourself. X minus 2 equals 0. So what would x need to be? You would add 2 to both sides. Oh, 2. 2 is what would turn that into a 0. I can already tell this one isn't going to work. It said -2, right? I'm just going to finish this one so you can see, though. 3x plus 4. What makes that 0? You would subtract 4 from both sides and divide by 3. -4/3. That's not 3/4. And then this one, x plus 5. X plus 5 equals 0. What would make that guy 0? Subtract 5, -5. Now, if there's nothing in front of the x, it ends up just being the opposite of this. But if there is something in front of the x, it's the opposite of this, but then you have to divide by that. Look, it was -4. That's the opposite of that, but then divided by this. So let's look here. This 0 is going to be 2, -3/4, and -5. Nope. -2 would make that 0. 4/3 and -5. Nope. -2, 3/4, and +5. There it is. All right, number 3. The graph of a polynomial has, f of x equals 2x minus 3 times x minus 4 times x plus 3, has x-intercepts at 3 x values. What are they? It's whatever makes each one of these equal to 0. You could do these in your head. I'm going to just show you technically what you're doing. You're solving each of those and finding out what makes them 0. This one you would add 3 and divide by 2. So this one is 3/2 or 1.5. This one, you just add 4. There it is, 4. This one, you would subtract 3, -3. So if you were to type that into Desmos, it's going to cross the x-axis at x equals -3, x equals 4, and x equals 3/2. Oh my goodness, an oldie but goodie from Unit 1. Match each sequence with one of the recursive definitions. Note that only part of the definition showing the relationship between the current term and the previous is given to not give away the solutions. One of the sequences matches 2. Oh, so they don't tell you what the starting term is. So this one, I think what I would do is come over here and figure out what's going on. This one I'm subtracting 4 each time. This one, so that one goes to this one, right? subtracting 4 each time. A goes to 1. This one is kind of easy. You're not adding anything, right? It's just 8, 8, 8, 8. That's this one. You know, they didn't give us the first term, otherwise we would have figured it out. And then one of the sequences matches. Oh, I see. Very sneaky. This one would also work because you're just timesing. What's 8 times 1? 8. What's 8 times 1? 8. What's 8 times 1? So that one works for that one. And then this one, we're multiplying by -1/2. Look how the sign changes. It goes from positive to negative to positive to negative. 1 times -1/2 is -1/2. -1/2 times -1/2 is +1/4. So if the signs alternate, it means you're multiplying by a negative. All right. Number 5. Han is multiplying 10x to the 4th by 0.5x to the 3rd and gets 5x to the 7th. He says 0.5x to the 3rd is not a polynomial because 0.5 is not an integer. What is the error in Han's thinking? The numbers in front of the variables can be non-integers. It's the exponents that have to be integers. So Han's error is he's applying the exponent property, right? The exponents have to be integers. The exponents must be integers, but the numbers in front do not have to be. So 0.5, that's okay. X to the 4th, right? If you want to see something that wouldn't be okay, it'd be like 0.5x to the 0.5. No, not okay. This can be anything it wants. Positive, negative, integer, decimal. This has to be an integer. Here are two expressions whose sum is a new expression a. Select all the values that we can put in the box so that a is a polynomial. So here's that idea again. When we're multiplying, we add exponents. We cannot let the exponent become a non-negative or a non-integer. It's got to be a positive and an integer. So if I put a -2 here, I'm just going to focus on this times this. That's the only one I'm going to focus on. If I did 2x squared times 6x to the -2, that would become 12x to the 0, which is just 12. That'd be okay on that one, but actually if I put, then let me just imagine if I did 5 times that. 5 times 6x to the -2 would be 30x to the -2. That is a non... I just realized I said something wrong on one of the other assignments. That's a negative integer. We can't have that. So nope, that won't work. If I put a -1 in there, I already know that one would be okay, but here that'd be 30x to the -1. No. If I put a negative number here, that's going to make that a negative. No. If I put a 0, that's going to be okay, because 6x to the 0 is just 6 times 1. It turns that into 6. And that x is x squared. We're good. I can have a half. Actually, nope, because if I did a half, 5 times 6x to the half, I cannot have, like we talked about it up here, I cannot have a non-integer for an exponent, so that one's not going to work. Could I put a 1 in? Absolutely. No negatives, no fraction powers. Could I put a 2? Yes. Okay, I think that might be it. All right, guys, I hope that helped. I will see you soon.